Another AI technique, intelligent technique. Okay, so we have two techniques. Okay, so two techniques or three techniques. The first one is neural network or fuzzy logic. Okay, whether it may be fuzzy logic, neural networks, and apparently genetic algorithms. Okay, so sometimes we're going for hybrid techniques. Already we have seen in the previous class, in the neural network class. So first we're going to see the fuzzy. Okay, fuzzy is always what is the fuzzy? Fuzzy indicates non-linear. Not clear, yes. Fuzzy is always not clear. Okay, as like you. Am I correct? As like programs. Okay, from your point of view, you are expecting the same thing from me. So you want a precise, you want a very clear. Yes? Okay, sir. So fuzzy indicates not precise or not clear. Okay, it not gives clear information, but we can able to interrupt. Okay, but we can able to interrupt into several functions. That means we can able to see the forthcoming slides. Fuzzy is flexible machine learning technique. Flexible machine learning technique. That's the thing. If you take the crisp set, okay, so we are not having that flexibility. Whether you're going for 0 or 1. If you take the fuzzy, yes, we can have the flexible interruptions of that. Flexible interruptions of that, but it should not be clear. So it should not be clear means yes, we can make it that things to be clear. Okay, but by seeing the first time, it should be give somewhat confusions. But if you work with the fuzzy, it gives the exact thing and comparing to neuro. So if I compare neuro to fuzzy, I say that fuzzy is the best when comparing to neuro. Okay, so flexible machine learning, okay, and mimicking the logic of human thoughts. Yes, what we are discussed in the neural network. Okay, the same thing as like our brain. It's also we have some discussions. The same thing we can find the outputs as like human brains. Next, logic may have two generally the conventional side. Okay, if you take the logic, Boolean logic and crystal logic, what happens? It having two values. Only that means two values and indicates two possible solutions. That means either 0 or 1. Okay, in 0 or 1, we cannot able to we are not having the possible solutions. But if you take the fuzzy, yes, between 0 and 1, we are having so many possible solutions of that. Okay, so fuzzy logic is a multi-valued logic and those intermediate values to be defined. Okay, here I am forgot to mention the conventional logic. Okay, so that if you go into conventional techniques, what happens? There's 0 or 1 or yes or no or true or false. But if you come into fuzzy logic, yes, between the two values, fuzzy logic can able to interrupt between these two values and able to say yes, this is wrong too. Whether it may be clear, whether it may be yes or no. This is a criteria which falls under partially true or partially false. Okay, that type of interruptions is impossible in the fuzzy logic. Okay, and provides on inference mechanisms which can interrupt and execute commands. That's a major thing. So you have the chance to inference. That means you have a chance to interrupt in the two values. That means this side and this side value, extreme values, and you can be able to give the exact solution. Okay, fuzzy. Finally, coming to say that not clear, distinctly or precise is called as blurred. As an image or noise, it should be blurred. But what I am saying that if you work with the fuzzy and if you are having wide knowledge, you are not able to say I am having that. You will not accept this thing. Okay, but as a student's point of view, if you observe this thing, okay, and you study this contents, yes, always it should not be precise. And it's precise but not clear. Okay, it somewhat makes confusion. But if you look at the fuzzy, once if you understand, yes, that is the best method in comparing the method and gives the exact solutions. Okay, first logic. The same thing. Again, form of knowledge representation suitable for rotations that cannot be defined precisely, but it depends upon the context. Yes, what I am saying that. So some of the candidates are having the what I am saying that if you take the average of students, okay, for example, the fuzzy logic, what is average of the students scored? What means around 67%. So I want to compare the students those are coming more than average is a good student. The students those are coming less than average is a moderate student. So good student. Okay, but I cannot able to judge. These are students who are coming above this average is called good student. I cannot and apparently I cannot able to judge the students those are coming below that average is not a it's a poor student. Okay, I cannot able to judge. Okay, so as what happens, we have to take the average and parallel we have to interrupt between these two extremes. Okay, then only we can able to find this. And parallel, as a student's point of view, yes, we can able to show interest on one subject and we cannot able to show interest in another subject. So So we have to consider all the subjects, and we have to consider all the average subjects, and we have to interrupt your marks with the corresponding averages, and you have to check you are a good student or poor student. Am I correct? So yes, you have scored around 6 CGPA in Fuzzy, but you have scored good marks in the field automation. So if by consulting other things, you are getting averages 8.5. Even though you scored 6 marks and 6 CGPA Fuzzy, you are saying that you are a poor student, but the total CGPA is saying that yes, you are belonging to normal person or abnormal person. Okay, that's the thing we can have as like same thing we can able to make analysis in the Fuzzy. Okay, so that cannot be defined precisely, precise thing, but okay, we have the interface to find out precise informations. Okay, we come into Fuzzy. Okay, evolution of the Fuzzy. First, 384 to 322 BC. Okay, what happens? Yes, we have the law of non-contradiction. That means they may be true or false. That is called a specific set of Boolean sets. Okay, we are not having any better interruptions of that. Okay, this is indicated by the Aristotle. Coming to the next, about 1917. Yes, the logician and philosopher. Okay, his name is called John Luca. Proposed a three-variant logic, either true or false or middle. Okay, true, false, and positive. That means this principle is known as the law of excluded middle. That means true, false, and positive means. It may happen. Okay, that's the thing. So you can able to predict. You can able to say that it may happen. Okay, true, false, and positive. Okay, so after 1917, yes, we are moved to Fuzzy. Okay, but still you are not into the entire Fuzzy. Okay, so we are moved to Fuzzy. Let's go to Fuzzy. A brief history of the concept of logics and the advent of fuzzy logic in the modern day applications. That means, yes, after 1917 only we jumped into Fuzzy. Okay, with respect to the thing of fuzzy logic is flexible. Fuzzy logic is constantly easy to understand. Okay, once if you work with the Fuzzy, it is easy for you. Okay, fuzzy logic is a tolerant of imprecise data. Yes, you can able to get the precise data and compare. Think of it, even though we have so many AI techniques on that, take genetical learner, take neural network. So if you learn these three techniques, okay, and as a researcher, as a learner, you can able to say, yes, fuzzy logic is excellent. Okay, and coming to this next point, fuzzy logic is based on natural language, our language. Okay, we can fix our strings in between the strings. Okay. In 1965, okay, in 1965, okay, 1965, 1985. In 1965, okay, the fuzzy logic is introduced by Zedek. Okay, Zedek is a famous person. Okay, he is the father of Fuzzy. Okay, and is the mother of so many fuzzy migrations. Okay, so Fuzzy, a professor of University of California, can introduce the Fuzzy methodology. That means 0. Okay, think of it, 0 to 1, 0.01. Okay, in between this, yes, we can able to have some interruptions. So we are not in this side or this side. For example, 0.5. If it comes under 0.5, you can able to say 0.5 is in this side or this side. For example, if you ignore is 0, 1, whether 0.4 is coming in this side or this side, you cannot able to say. Okay, as the conventional side, yes, 0.4 means it's not following 0 and 1. So you cannot able to say. But yes, you can able to judge 0.4 is coming this side or this side. Okay, so that type of interruptions he defined. And if you coming to 1985, the same professor expanded. It's a very interesting technique, but it's not new syllabi. Okay, the same professor. So before it was a Fuzzy. Okay, he introduced the Fuzzy with some basic knowledge only. Okay, this is some basic inferences. After that, he jumped into the decision making. Multi-criteria decision making is a very important technique. Okay, for research. Multi-criteria decision making technique. Okay, MCM, we can say that my MCM, but it is not in our syllabi. Okay, it is also coming into Fuzzy. Detailed Fuzzy. Okay, so in our new syllabi, it's only basic Fuzzy is there. Okay, so detailed Fuzzy, who is working, already is working this thing. Okay, multi-criteria decision making. So he jumped from basics to MCD. This is called as MCD, multi-criteria decision making. And after that, okay, after that means in 1965 itself, he finalized the Fuzzy with with all the things, and parallel jump, he incorporated that fuzzy with some other techniques that is called as multi-criteria decision making. Fuzzy is there. Okay, fuzzy is here introducing the fuzzy. Here we're taking the fuzzy here. Okay, the fuzzy is used for analyzing the important weights, analyzing the weights. For example, can able to say, okay, who is the topper of your class? Who is the topper of your class? Who is the topper of your class? Okay, what you are saying? What you are saying? He scored good CGPA in first semester, second semester, and third semester. These are the weights what he is achieved. So depending upon the weights, you are saying that he is the best person. Okay? Yes. As like that, we are having so many persons are there. Okay? So all the percentage will be calculated, and depending upon conservative persons, you are saying that he is the he is a good performer in compliant to all the ways. Am I correct? Is it correct? Is it correct? Is it correct? No. Is it correct?
Yes.
Yes, that's the thing, is main important. Okay, according to college aspect of views also is, we cannot able to say who is the best, who is the worst. Okay, because since I want to say the best performer, the college is giving the best performance award for the student. Okay, how they are selected? Based on the marks is the eligibility to enter in the criteria, that enter into the aspect. Then apart from that, is punctuality, discipline, alternance, and what are contributions done for VIT, what he achieved, what he bring the laurels to college. All the things are put together. All the criteria will be considered to select the best person. Am I correct? So if you have so many criteria, okay, let's put for selecting the best performer. Okay, think of it. I'm having 60% are eligible to select that. 60% are eligible. 60% I'm opening for call for. I'm giving call for. I'm going to select the best performance for VIT 2030. So the early students can able to apply. These are the criteria to be followed. Like if you have these criteria, yes, you can able to apply. Okay, around 90 students are applying for getting the best performance award. How are they going to select? You are actually selecting the best performance award. These are criteria to be considered. Okay. Then different categories and different types of weights. For example, so in respect to research, think of it. In respect to MTech category, they are giving more importance to research journals. In respect to BTech category, they are giving more importance to patents and research, patents and journals. The project is converted into patents and journals. If you are having patent, yes, you will be credited. But even though if in MTech you are having patents, it should be given. Some guys are having journals, some guys are having patents. But they are giving recognition, more recognition to journals, less recognition to the patents. As like that, okay, the weights may vary. What happens? That's the thing. Okay, it's followed here in multi-criteria decision making. The MCM is there. Okay, so we have so many criteria. Okay, we have so many criteria to, for example, to select the best performance. Yes, it is possible. With this technique, it is possible. Not the basic fuzzy. Okay, we want to select the weights from the fuzzy, with help of the fuzzy, and we have to take the weights to some other technique, and we have to find out who is the best performance among these criteria. If you have 90 students and 10 criteria, you cannot be able to find each and every person doing mathematics. Yes, if I am the calculated person, if I am the selected person, what happens? I am the selector. Yes, I can able to give more priority to MTech mechatronics students and combined other students. Am I correct? Okay, if another guy is there who is coming from electronics background, he is giving more preference to electronics. So that means somewhat flexibility for electronics students there. For MTech mechatronics, he is giving 0.5. But the same category is applied for the student means, since he is or he or she is the MTech, he or she is electronics students, he can give 1 mark or 0.75 marks. Okay, so what happens? That 0.5 indicates plays a very important role in selecting the best performance. Think of it. Okay, so yes, so we have a ready-made thing, the Excel file. Okay, we can calculate the weights, and if we put it the grading, what are things is good. Put that means it shows Sai Samant is the best performer when comparing to as like that, it shows automatically. Okay, that's one of the techniques following here. It's not in syllabus. We coming to next 1987. Okay, yes. So what ZDAC find? What ZDAC discovered the fuzzy? Okay, made an attempt with the real-time application that is called as modular train in Japan. Okay, the first survey system was built, which worked with the first logic based automatic train operation system in Japan. and finally it's succeeded. Once it's succeeded only, the fuzzy comes to the academic side. That means the fuzzy names moves up. Again, what happens once they incorporate the fuzzy system and say yes, the fuzzy is really doing something. Okay, the fuzzy is the best controller in compared to PID controllers, PA controllers, and some other controllers. Okay, so then only the fuzzy plays an important role in the academic side, the controller side. Yes, now we are working with so many hybrid techniques, neuro fuzzy, okay, and neuro genetical fuzzy genetical so many things are going on. Okay, sir. So essential characteristics of fuzzy logic is founded by ZAC. What are characteristics is founded? In fuzzy logic, exact reasoning is viewed, okay, as a limited case of appropriate reasoning. Okay, we can view the appropriate solutions. Okay, so whether I'm having reading of 0 and 1. So for example, 69.5. This is good. This is bad. So if it comes around 64.5, then it's good or bad. Yes, we can able to say that is appropriate reasoning. In fuzzy logic, everything is a matter of degree. That means degree of recursive function. So any logical systems, what are things? Any logical systems can be falsified. Okay, any logical systems. Yes, we are going to do an exam in lab view. Okay, what we have done, what you made an attempt in the neural network, the same readings. You want to take the same reading, and you want to make an attempt in that lab view software. That any logical systems, if any logic is there, okay, yes, it's possible in the fuzzy. So in fuzzy logic, knowledge is interpreted as a collection of elasticity or equivalency. Fuzzy constant the collection of variables. That means we have some elasticity is there. Okay, for example, 64.5, we have the flexibility of partially true. Sometimes it comes partially true or partially false. So we have some flexibility. You're not able to say this is true. You're not able to say this is false. But this is partially true and partially false. Okay, that type of flexibility is there. Okay, if you take the CGP system, you're not able to say pass or fail. Am I correct? Say that type of logic is not applicable for our academic side. But this type of logic is academic, it's possible for our academic, not apart from the academic side. Okay, if you come into real-time scenario, yes, this is possible. Okay, partially considerable, or not partially considerable. Okay, that type of things are elasticity is that. Inference, yes, behind the inference means that means inference is that. Yeah, we can go between these inferences and be able to find this in, for example, 68 means this is belongs to this category, or which category. Okay, it's possible. Inference is possible within this elastic constraints. Yes, it is possible. Okay, that's a thing is founded by the ZR. Okay. Okay, sir. So if you're coming to fuzzy logic, okay, what it means, fuzzy logic is a superset of Boolean. Okay, Boolean logic that handles the concept of partially truth, which is truth, that is between completely true and completely false. What I am saying that yes, the Boolean conventional function, it only indicates true or false. But in a fuzzy set, we cannot able to say true or false. Sometimes partially true, sometimes partially false. Okay, sometimes partially true, sometimes partially false. That is saying the fuzzy logic. Okay, fuzzy logic is a multiple value, so you do not have the exact value. Yes, the person is having pass. Yes, the person is bound to fail. You can able to the academic side. You come into the real-time scenario, you cannot able to say this is true, this is false. So it may be sometimes partially true, sometimes maybe partially false. Okay, we have the chance that for the type of flexibility is that is called as multi-value. Okay, that is, we can say that in other words, degree of memberships or degrees of truth. So degrees of truth means partially true or partially false. Okay, so we cannot say that it's true. Somewhat true and somewhat false means yes, the answer elasticity is that. That means degree. So degree between these two. Okay, degree of membership, partially true is one function and partially false one function. So we have the degree. That means we have some flexibility between the partially true and partially false. That is called as multi-value. Okay. So fuzzy logic uses the continuum logic. Yes, fuzzy logic uses that. Fuzzy logic is extracted from the Boolean function only between 0 and 1. Okay, but we have the possibility to interrupt between these two inferences, 0 and 1. Okay, we have the possibility to interrupt between two references. Okay, for example, what is the point? What is the value of point? What is the value of 0.833? Okay, if you say that 0.8 is false, 0.6568. What is the point? Is it 6568? Is it maybe true or false? We are not able to say. Okay, yes, fuzzy logic is having the type of flexibility we are able to say, okay, true or false. Okay. So examples for crisp set and fuzzy set. Okay. So if we take the crisp set, what happens? For example, let a 100 ml glass contains 30 ml of water. Then we may consider two concepts, empty and full. With respect to conventional logic, we can able to say empty or full. Am I correct? As what you are doing in the academic side, pass or fail. So in Boolean logic, crisp set, there are two options for answer. That is either glasses are full or glasses are empty. Am I correct? So we have 100 ml is there. 30 ml of water is there. We can able to answer this half full or half empty. Okay, that is partially 70% full and 30% empty. That is the answer for Boolean logic. If we come into crisp set, what happens? Yes. So in fuzzy concept, fuzzy set, one might define the glass as being 0.7 empty and 0.3 full. Okay. In fuzzy set, we can able to say exactly. That is degree of membership function. This is called as 70%. It is called as 0.7. This is called as 30%. This is called as 0.3. If we take the Boolean logic, we can able to say the glass is full or empty. Okay. We cannot able to say 0.7 is full, 0.7 is empty, and 0.3 is full in fuzzy logic. Okay, sorry, in Boolean. But if you take the fuzzy logic, yes, you can able to say 0.7 is empty and 0.3 is full. We cannot able to interpret this type of data in the Boolean logic. That's a major problem. Okay. Okay, sir. First is a crisp set. So if we take the crisp set, what is this set? Okay, this set is having so many elements. Okay, so A is a member of crisp set A and B is not a member of set A. For example, take it. Set A. Set is having A, B, C, order elements is the A1, A2, A3. What happens? We're giving the answer. We can check it whether A is going to this set or not. Yes, it's saying that A is going to this set, but B is not going to this set. That's the thing. Either true or false it indicates. Okay, but if we come into this side, can you check it? First is A. If we find that A is there in the first set only. Here first set is indicated as A dash. Here on its set is called as A. First set means you want to indicate dash. Okay, always. So A dash and A. In first set A dash. A, yes, we can able to say, I am saying that A is a full member of first set A dash, full member. Okay, here it is a member, but here it is a kind of thing that words, it's a full member. If we coming to B, not a member. If we coming to C, partial member. But we cannot able to find this techniques here. That means whether it's true or false. But here, yes, it is partially correct, it is fully correct, it is not correct. Okay, that's the thing you are saying. Okay, the crisp set, yes or no. Are you on? Definitely. Why not? Okay. Another option is that not that much. Okay, so that means there are so many possibilities are there. But if you are not in the same set here, you can able to say yes or no. But if you come into fuzzy set, yes, definitely. That means you cannot able to. Definitely means the answer is correct. If you don't do that 9.5, yes, I can able to accept. Definitely means that's all. You can able to accept. They want to means it indicates yes only. Partially yes. That's the thing they are saying. Why not? Other things. Okay. So we have so many options of that. We have so many interferences of that. Okay. We have so many interferences of that. The first case crisp set. So can you think of it? Okay. So there are three persons of that. The first person is having age 5, second person is having age 18, this thing is having age 30, 25. If you take the crisp set, person who is coming under below 20 is that it indicates a function is 0. So if the age is crosses 20, yes, it belongs to 1. Okay. So if you take the crisp set, what happens? Even though it's person is 5, it belongs to 20, yes, it indicates 0, output is 0. Again, that means membership function is 0. Then or you can say that 2 or is not having eligibility, not eligibility, this is eligible. Okay, even though you are having age 18, coming into age 18. So think of it 5. If 5 is not having eligibility, 18. What is the difference between this 18 and 20? What is the difference between 18 and 20? Only 2 years. Am I correct? So with the reason of only 2 years only, he is not having eligibility in the crisp set. Okay, but if you come into this side, partially eligible is there. That's the thing. There's partially eligible is there. Say the 0.70% is eligible is there. 70% of eligibility is there for that person. Okay, but if you come into that, even though he's having less than 2 years experience, for example, if I take you going for interview and they're saying that the person is want to take you, so want to find out the person is having more than 20 years experience. What happens? So you are having 19.5. You're coming in this case. Okay, if you are having 20.1, you're coming in the case. Okay, that's a problem. Okay, that's a problem. Okay, so think of it. Okay, so but if you come into fuzzy state, if you fit the fuzzy state, what will happen? Yes, the person is having eligibility of 70%. Can you leave that person? Okay, not eligible for this person is having the eligibility of 73%. That's the thing they are saying. Okay, age is less than 6 years, is eligible. Not eligible. Age is greater than 20 years, is eligible. But here, what happens? If you are having 18 years, yes, it is already eligible. 70% eligible. So if you're going for real-time simulation, if you're checking the real-time things in your simulation software, yes, whether you can able to accept 70% result is true or getting 70% result, they can able to accept or not. They are accepting 70% result or not.
But 0, 70% is also right. And compared to 0, 75 is also.
Compared to 0, 70% is also. If you take the academic side, so if you scored 100 mark, yes, what we are giving? You are giving a stopper. If you scored less than 45, you are giving the name as fail student. What about the remaining students? 60, yes, is also pass. 65 is also pass. 73 is also pass. 74 is also pass. Why you are saying that you are not accepting 70%? Okay, if you are saying the same thing, then in the real time academic side, I need only around more than 90 students eligible. If you score more than 90, yes, they are the students eligible for some other categories. They are students eligible for some other purposes. The student those are having 90%, again, is not eligible. The student those are having more than less than 40% is purely is negligible, is avoided. But what about from 45 to 90? They also scored something. So we want to do some consideration. Again, but you have to do some consideration. Again, you have to do some consideration. But it may vary depending upon the situation, applications. So if I give you, if you access 70% student automatic autonomous control side, that's all. Okay, your car will be trapped in some other car. That's a problem. Okay, so if you take the hazardous plants or nuclear power plants, yes, 99.9% should be there. Okay, if you take the boiler side, yes, 80% is more than enough. Okay, boiler side. If you take process plant and all, think of it, they're expecting only 78% of output only. Okay, the process plant will not able to get it 100% output, that means 100% productivity. Or think of it, 90% productivity is not possible in the process plant. That means in the industry, pulp industry, paper industry. Okay, if you discuss any other process, top level process, they said that we are gained only, so this year we got only 60% of productivity, 65% of productivity. Okay, we are focusing for 70%. For them, 70% is the highest target for them. Okay, so for that type of plants, we can go for fuzzy. Okay, you can go for fuzzy. Okay, sir. So we cannot able to say what is related to the academic side, slow or fast. But if coming to physiologic side, okay, we can able to say they are slow learners. So we are giving the name of slow learner. What do you mean slow learners? So if you are coming this category, yes, he is not eligible for anything. Okay, he is a topper. The remaining things are not slow learners. We want to move them. So we want a separate counseling with that advice. So to uplift his slow learners. So we are using so many things, okay, for this thing, for the inferences, between these two extremes. Okay, sir. Why not fuzzy logic? What is the fuzzy logic versus neural networks? Okay, how does a neural network work? Yes, neural network works with these concepts only. Okay, already we have seen with respect to weight systems. Again, with respect to input layers, output layers, and hidden layers. Okay, but what we are saying, yes, both the networks, both the techniques are related to the human brain only. Okay, both the techniques we are saying that coming under the intelligent techniques. Intelligent techniques. Okay, intelligent technique means what happens? Similar to the of human brain. Okay, blindly you can say similar to the of human brain. Okay, so we can actuate several processes, parallel processes. Okay, so both used to create behavioral systems only. Okay, but what's the difference? Yes, we're going to find the difference in your real-time system. That is in your lab software. That means in your real-time simulation in your lab software. You're taking the same readings, what we might have done in the neural network. Okay, the same readings are going to fuse in the lab view fuzzy. We're going to check the readings, and finally we have to compare this fuzzy and neuro with the performance, and you have to say which is best. Okay, that's the thing we're going to see in the forthcoming classes. Okay, so anyway, we can finish up with this 3 or 4 slides. Okay. So membership function is that. What are my membership functions? What we have said that yes, 0 and 1. Okay, in between this we can fit this 0.75. Yes, we can able to say 0.75 is having the 70% is that. That is called as membership function. 0 and 1. In between this we can able to fix some values. Okay, so we can fix some task. That is called as membership function. We can able to say 0 and 1 degree of membership. Okay, 0 and 1. In between that we can able to find which degree is suitable for this function. Okay, that's the thing. Map elements of first set to real number values in interval 0 to 1. Yes, we are in the values of 0 to 1. Okay. The curve indicates the mathematical function is a membership function that determines the degree of belonging of membership x to first set t. Okay, x to first set t. For example, freezing is that, cooling is that, warm is that, hot is that. Okay, for example, I am 25% degree Fahrenheit is that. What happens? 25% Fahrenheit is that. Can you able to say what's the degree of membership function? That means you can able to say 4, you can able to say 6. So 0.4 is belonging to 0.4 is belonging to cool. 0.6 is belonging to freezing. Okay, yes. So we can have degree of membership functions like that. We're going to see next slide. Fuzzy sets. Okay. So we can able to use the fuzzy set A and fuzzy set B. Okay. Fuzzy set A and fuzzy set B. So and finally we can say this is a if we incorporate 2 fuzzy sets, A intersection B, A union B, and find the complement of A. So if we incorporate these 2 fuzzy sets, you can able to find which is intersection. This is intersection. Apart from this, the remaining is a union. Okay, complement means complement of A means this is A fuzzy set. Whatever this complement means is inverse of fuzzy set B. This is not needed for you. Okay.
Sir, what about the value is 4.5?
4 point?
The intersection point.
This point.
Yes, sir. What will be this?
I will inform you. Just you can observe it. Exactly. Good. I'll come to you. So this is being rectified in the lab software, when you work in software. Anyway, I'll come to you. So if you come to example for fuzzy point, fuzzy set, we are having 2 inputs and 1 output. Okay. We are having 2 inputs and 1 output. Okay. So one input deals with temperature, another input deals with cover. Cover means, for example, temperature indicates several parameters: freezing, cool, warm, and hot. Okay. Freezing, cool, warm, and hot. Coming to cover, what is the cover? What is the cover? Who is sunny? Sunny, partly cloudy, overcast. That means climate condition. Okay. Temperature, freezing, cool, warm, hot. That means temperature rate will be reduced. The sky will be clear, partially clear, fully cloudy. Okay. So what happens? Yeah, so already the output is cool means 30 to 50, 30 to 70. Warm means 50 to 90. More hot means more than 70 degrees. Freezing means less than 50 degree temperature, 50 degree temperature. Coming to cover, that means the intensity of sky. Okay, somewhat sunny means 0 to 40. 20 to 60, 20 to 80 is partly cloudy. Overcast means it fully covered with the cloudy. That means fully cloudy. It's called as 60. Okay, coming to output. Okay, you can able to say the output is slow and fast. That's all. Okay, slow indicates more than 30%. So fast indicates more than 30%. Slow indicates 0 to 70%. Okay, so we can say that this is a triangular membership function. For example, I'll explain the membership function also in the forthcoming slides. For a triangular membership function, what triangular membership function means? Think of it, cool. So 30 to 70. 30 indicates membership function is 0. 70 indicates membership function is 0. Cool indicates membership function is 1. That means it comes to the triangular state. So okay, So Fuzzy is having three membership functions. One is triangle, second is trapezoidal, and third one is so why you are going for triangular, why you are going for trapezoidal, why you are going for quasi? Again, yes, once you work with the lab, you will be able to understand. Anyway, I will explain to you. Okay, so I will explain the forthcoming slides. We have 2 slides of that. Okay, so if speed indicates slow, so there are 2 outputs, slow or fast. Okay, there are 4 parameters for the temperature and 3 parameters for the cover. Okay. Rules, we are fixing some rules. Okay, so for that you have to find out which is the output. If it is sunny and warm, drive fast. If it is cloudy and cool, drive slow. Okay, so what happens? If it is sunny and warm, drive fast. Okay, sunny comes to the cover, warm comes to the temperature. Okay, the first speed should be high. What is the speed? Okay, what is the speed? Coming to cloudy and cool, what is the speed? The speed should be slow. That is a rule. What you have framed from by you. Okay, yes, you can fix your rule. Sunny and warm, you can fix slow. Okay, cloudy and cool, you can fix fast. You can fix the rule. Okay, you can fix the rule. Okay, so what happens? So I'm going to take some fuzzification. This is a fuzzification. Fuzzification means we have to find out what, for we are giving the input values. Okay, calculate the input membership values. That's called as fuzzification. What will be fuzzification means? Think of it for 65 degree Fahrenheit. I'm giving some input to 65 degree Fahrenheit. For 60 degree Fahrenheit, yes. What happens is for 60 degree Fahrenheit is indicated with that cool and warm. Okay. So for that what happens? This indicates the value of 0.4. Okay. This is indicates the value of 0.7. Okay. That is called as, that means whatever the values are there, that will be converted into degree of membership functions. That will be converted into degree of membership functions. That is called as fuzzification. Okay. Whatever the values are feeding there, 65 is there, but you're not getting the degrees of 65. Okay, all the degrees are converted into between 0 to 1. Between 0 to 1. That means 65 degree Fahrenheit is having the eligibility of 40% cool or 4%. That means 0.4 is there and 0.7% in the warm sectors. Okay, so that's the thing is called for 65 degree Fahrenheit. If you come into 25% cover, again, what happens? 25% means yes, cloudy is 0.2%, sun is 0.8%. Okay, whatever things are giving this input, it will be converted into the corresponding degree of membership function. Okay, so what happens? 0.2 and 0.8. If it is sunny and warm, drive fast. That's the rule. Am I correct? What if it is sunny? What's the value between sunny? What's the value of sunny? 0.8. Am I correct from the cover? What's the warm? 0.7. So 0.8 into GAN get 0.8 into 0.7. What is the output? What is output? That's the thing. This is things you are able to find from here. So 0.7 is possible with 0.8. 0.7 comes to the limit of 0.8. 0.8 comes to the 0.7. So 0.8 is the last fit. The value getting 0.7 is able to fit here. But 0.7 is AND gate. 0.7. 0.8 is coming into this limit? No. So what happens? 0.7. So what your first value is 0.7. Okay. So coming to the next category. Cloudy and cool. Okay, what is cloudy indicates 0.2. Cool indicates 0.4. Okay, so if cloudy and cool drives slow. Okay, so cloudy is 0.2, 0.4. What happens? 0.2 fits in the 0.4, but 0.4 not fits in 0.2. So answer is 0.2. Okay, slow, fast and slow. They're coming fast or slow. What are things coming? You say that fast. What are things coming here? This is called as slow. That's all. Okay, we cannot able to say. So we are able to calculate from this thing, we are able to calculate from this thing. So what are things getting here? We already fixed the root is fast. So that's is called as fast. We already fixed the root is slow. This is called as slow. Okay. Okay, if we come into defuzzification, yes, I want to find out the remaining, I want to find out the value, I want to find out the speed. Okay, I want to find out the speed. Okay, kindly check it. Kindly go to the slide. Okay, what happens? Yes, we are in the temperature, we are in the cloud cover. Okay, and speed is there. So I want to know the value of 60. I'm giving 62 degree Fahrenheit, and for 25% cloud cover, what is the output? Okay, so what happens? Yes, we are going to calculate the fuzzy. For 65 degree Fahrenheit, this is the membership function. For 20 degree Fahrenheit, this is the membership function. Okay, okay. So coming to the Defuzzification, yes, you want to convert that value. You are saying that speed is 20% slow and 70% fast. What this is getting from fuzzification. Okay, again you have to defuzzify. That means again you have to defuzzify means again you have to denormalize. That means denormalize. Denormalize means yes, you can able to find the values here. Okay, therefore this membership function. This is got as this is coming under the degree of membership function. We have to extend the degree of membership function into original value. Okay, so fuzzification means original value into degree of membership function. Okay, that degree of membership function will be extended into original value. This is called as defuzzification. This is called as fuzzification. Okay, this is called as fuzzification. So speed is 20% slow and 70% fast. Okay, so what happens? So 20% slow. So this is output. We have to draw a vertical line and while you think of it, this is 20%, this is 70%. Okay, draw a vertical line. So what happens? This will matches here and this will matches here. Okay, so this is one of the methods, centroid method. Okay, centroid method means you have to draw this line. Okay, you have to draw this line. Okay, what happens? This line will meet to 20%. This line will meet to 20% because this is fast, this is slow. So this line want to meet with slow. Centroid of the slow line. Okay, 70% want to meet the centroid of the fast line. Okay, then you can able to spray out find this is speed. Okay, speed is going to go 2 into 25. 2 into 25 value. What the value? Plus 7. 70% into 75 divided by 7 plus 2. This is called 9. So final answer is 63.0 millimeter per hour. Okay, so what happens? Fuzzification means the original value is converted into degree of membership function and degree of membership function is converted into original value. Okay, so for this thing you are fixing some or between 0 to 1. You are fixing some values in between 0 to 1 and finding the task, and that task will be cross-checked with the task, and that task will be cross-checked with the output. Okay, with the help of fuzzification process. Okay, with the help of fuzzification process, that is called as defuzzification. Fuzzification. Okay, so coming to fuzzification, the process of transforming the crisp input values into linguistic values is called as fuzzification. So what happens that if it's 64%, yes, we are converting into the linguistic values between the 0 to 1, between the membership function. That is called as fuzzification. Okay. Step 1, input values are transferred to linguistic concepts which are represented by fuzzy sets. Step 2, membership functions. Okay. So we have to apply the real value here. Okay. For example, think of it 75. Then what happens? This is the real value. That real value can able to interrupt here. The degree of membership functions. And what happens? This is the linguistic values. So remember, whatever the values given by you want the values want to enter the linguistic variables here, and for the linguistic variables you have to find the membership function. Okay, degree of membership function. That is called as fuzzification. Okay, that is called as fuzzification. Coming to defuzzification, yes, defuzzification converts the fuzzy value into crisp value. So what they are happening here, they are converting the crisp value into. So if you give it 65 degree Fahrenheit. Okay, so it is interfering in the linguistic variables and finding out degree of membership function. Once you find the membership functions, we are fixing the roots, and these functions are checking the roots and finally getting the output. For getting the output, then again the degree of membership functions will be converted into the crisp values. Okay, so crisp into linguistic variables, it's called as fuzzification. Then the fuzzy values. Can you think of it? Fuzzification means crisp value into linguistic values. So linguistic value is not a fuzzy value. Linguistic values. Okay. So in the help of the fuzzy inference, fuzzification, then fuzzy inference, then defuzzification. There are 3 steps are there. Can you note this is most important. Fuzzification, so converting the crisp values into linguistic variables. Then fuzzy inference, and so fixing this linguistic values into degree of membership function. What we have said. So 60 degree Fahrenheit coming 0.4 points out. This is called as fuzzy inference. Okay, and parallelly you are fixing the roots. If then rule. This is called as fuzzy inference. This is called as fuzzy inference. Fuzzification means converting the crystal values into register values. That's all. Fuzzy inference means, yes, for the register value you get the numbers of function and you're fixing the root. You can do. That is called as fuzzy inference. Finally, if we create a rule, you will get output. The output will be converted. That means it is in the fuzzy value. Fuzzy value is converted into crystal value. That is called as defuzzification. That is called as defuzzification. Three major important parameters. Three major important things to be considered for fuzzy. You are working in the lab software. Yes, these three things plays an important role to find out the final crystal value. Okay, yes, well, one of the things is very good in the lab software. So, finally, I want to stop this point onto TPD. So, types of fuzzy function is that quasi-fuzzy membership function. Okay, quasi, that is somewhat semicircular. Quasi-membership function. Again, think of it. So, in the diagram you can see that. In the diagram you can see that. Okay, so the limits. What are things we are giving here? It is fitting this to linguistic variables. If I am giving this that, if I am giving this that, what happens? It joins here and it joins here. Okay, so what happens? This is called as triangle membership function. 0 or 1. In between this, we are giving some reading, and the readings we can able to the readings are equal to the linguistic variables, and we are finding the fuzzy inference. Okay, so what happens? This is a triangular membership function. This is a triangular membership function. 0, 0, 1. So for triangle 0, 0, 1, 0 to 1 only. 0 to, sorry, 1 only. Again, but if you come in quasi, see, -2, 1, -1, 0, 1. So we will avoid this thing. Okay, we will not, researchers will not provide that, we will not go for quasi first function. For triangular, yes, 0, 0 to 1 only. Okay, so coming to this side, of this side, think of it. 0, 0, 1, 1, 0, 0, 1. Can you able to say triangular is 0, 0, 1, trapezoidal is 0, 1, 1, 0. Which is best? Any one from the class. Why?
So depending on the application.
Why? So think of it. Snag it. Can you able to say? So okay. You are working in the trapezoidal, but you are not saying that. Already working with triangle and you are going to work with the trapezoidal, you are not able to say. That's the thing. Okay, boss. So think of it. 0 to 1, we are in gap. 0 to 1, we are in gap. Okay, we are in 3 inferences. Am I correct? But we are in 4 inferences. Okay, that means gap is got. For example, okay, if I am giving this reading like this, what happens? I can able to find this thing only. Okay, if I am giving this reading like this, what happens? Here, if I am giving this reading, what happens? You can able to find this reading here. So I am not able to say exactly. Anyway, you can see in the function what means what is it? We are in 4 points. We are having 3 points. Okay, kindly think like that. So what happens if you are in 3 points? What happens? First in S, we get the result around 90%. To go for triangle membership function, we are in 4 points. 4 inferences of that, we get the result is significantly 80%. Okay, the same input and same output. Try to create a rule and try to make an attempt at the triangle membership function. You get the result of 90%. But for the same thing, try to make an attempt at the trapezoidal, you get the result of 90%. That means trapezoidal for trapezoidal membership function, we are in 4 inference point. You get the result exact. But what happens? He is having 1 point, 1 point. Here, what happens? 1, 2, 3. 3 inferences of that. Okay. So yes, we never get the result. Okay. That means in between this state, we are in inferences. Am I correct? Okay. So 1, 2, 1. But going to trapezoid first, second, third. Okay. This 3 inferences will play the important role, getting the degrees, so getting the values accurately. Okay, sir. We can list. So morning first systems, because we don't have our time. That's the thing. So Step 1, choose the related input and output variables. Again, determine the number of linguistic terms associated with each input and output variables. Going for what type of membership function. Next, select the type of fuzzy systems. Again, fuzzy inferences. Again, and you have to select the rules. You have to create a rule, if-then rule, and after that, if you create a if-then rule, you have to train with the fuzzy, you have to train with that fuzzy software, and finally get that output in the form of fuzzy values. We have to convert that fuzzy values into the crisp values. Okay, these are the basic steps to follow in the modeling the fuzzy system. What you are going to follow in the software. What are limitations? What are applications? Yes, I am going to stop here. What are limitations? Yes. Fuzzy logic lacking the capability of machine learning as well as neural network type pattern recognition. Yes. What happens? It will block the neural network system. Okay. So in comparing neural network fuzzy, fuzzy is the best. Okay. But what happens? If you have more number of readings, we want to create a rule. Okay. What I'm going to make an attempt with you. Okay. So for learning neural network, it takes time around 2 hours. You take a time of around 1 hour to 2 hours. But for same thing, you have to make a fuzzy means it takes around 10 hours continuously. For understanding the rule itself, it takes so much time. And again, you want to check the rule is properly coming or not. But in neural network, it's not thing. If you're giving the input and output and going for training, you have to get the results and you're going for the comparison. But if you're going to fuzzy, you have to check each and every rule. And number of values going, number of inputs is going and increasing. Okay. So number of input means I am having 2 inputs. 1, 2, 3 or 3 outputs. 1, 2, 3. And I have readings of 30 readings. Okay, what happens? So again, we have to create rules for 2 inputs, 3 outputs, and having 30 readings. Okay, here are the 30 readings. 2 inputs and 3 outputs is somewhat difficult. And if I want 2 inputs and 10 outputs, the task is very difficult. The task is very difficult. Okay, same thing we are going to make an attempt. Okay, the lab software. For that, we need around 3 to 4 hours for continuous understanding. Okay. Anyway, once if you understand the thing, once if you make an attempt at the thing, it's very, very easy. Okay, what happens? Yes, that's a major drawback in compared to the neural network system. But let's put the results. They exactly give the answer. Fuzzy in compared to neural network. But what happens? This fuzzy inferences, if that rule, we have to check for this 2 input with 10 output. Okay, how many rules can able to check it? How many rules can able to come? How many rules come? Around 30 rules will come. Am I correct? 30 rules will come. So 30 rules we have to check. We have to check. Okay, we have to check. It means I will inform to you how we have to check. So 30 rules we have to check. Means it takes around 3 hours. If you continue practicing, it takes around 1 hour. Okay, if you not have practice, it takes around 3 or 4 hours. And probably again, it gives a fuzzy thing to you. That means it produces some confusion to you. But it's not happening in neural network. Neural network is giving the readings, copying and pasting the Excel, and eventually you will get the results. But it's not like that. You have to find the rules, you have to check the rules, you have to modify the rules. If it's not correct, you have to modify the rules. Okay? Okay, sir. So determining the exact fuzzy rules and numbers of functions is what task I say. Exactly. Determining the exact fuzzy rules. That's the thing you're going to say. In your syllabus, you have 2 units. So the 2 units is combination of only 1 unit. Okay? But neural network is having 3 units. Coming to fuzzy, what happens? Trying membership functions, creating membership functions, and getting the values. That is the 1 unit. And parallelly, you have if you come to second unit, you have to modify the membership function. That means you have to modify the rule. If the rule is not properly occurred, you have to modify the rule. Okay? That is the second unit. What happens? For modification, it takes a lot of time. Okay? That's the thing, it's a hard task. Coming to applications, yes. Once it is used, the fuzzy logic controller gives the exact thing. Okay? And finally, you can able to apply prediction diagnostic applied systems, domestic appliances, so in Japanese trains, so VLSI systems, and finally software building techniques, and automatic control system side, automotive electronic side also. Okay. So far what you have learned, what is the step, what is my first step, about the introduction of fuzzy, okay, what are the components of fuzzy, fuzzification, fuzzy inference, and defuzzification, with some examples, okay, and what are the limitations. Okay, so for coming to next class, try to take your lab and try to install the lab use software in your lab. Okay, that means lab use software with the option of fuzzy control. Okay, anyway, I am going to teach the basics only. So 2 input and 3 output. Okay, 2 input and 3 output. Okay, and after that we are going for 2 input, and 10 out. Once if it is trained, that's all. Your chapter, your subject is finished. Okay? Because modification of rule-based function. Once we explain all the things, yes, some guys can able to understand, some guys not able to understand. But if you make it the same thing in real time methods, then you can able to understand. Okay? That's the thing we are going to do in the remaining classes.